Welcome to Abhiram IAS Academy. So in this session, we are going to start our actual concepts and all the things. So as we discussed earlier, we will start discussing about the number system and then we will move to learn different concepts from this number system. Now see here, when it comes to the numbers classification, what is happening to this number classification? So we all know that from a complex number, usually we call a plus ib and a complex number. A complex number is denoted with a plus ib, a plus ib. Now what is this a and what is this b here means? Here we call a as a real number, a as a real number, and b will become an imaginary number. B will become an imaginary number. A is a real number and B is a imaginary number for us here. A is a real number and B is an imaginary number for us. So we will take the help of this one. Now see here the same thing. A plus IB. If A plus IB is a number, then here A will become our real number and B will become the imaginary number. So we will not learn much about this imaginary number, but we should know one thing regarding these imaginary numbers, that is I square is equal to minus 1. I square is equal to minus 1. Apart from this, we will not much, we don't require that imaginary numbers. We will just learn that one. Now come to these real numbers. These real numbers are further divided into two portions. One is irrational number and the other one is rational numbers. So what is meant by rational numbers means, please observe, any numbers which can be written in the form of p by q. Any number which can be written in the form of p by q, we call that as a rational number. Okay, any number which can be written in the form of p by q is called a rational number. Now what is meant by irrational number? Irrational number means any number which cannot be written in the form of p by q. Then we can call it as irrational number. So what are the examples of these irrational numbers? Means pi. Sir, why pi? Pi, we know that pi value we will take it as 22 by 7. What actually means is pi's exact value is not 22 by 7. That is just an approximated value for the calculation purpose. So pi is not a rational number, pi is an irrational number. And square root 2, root 3, root 5, all the root values are also imaginary numbers. Don't say that, sir, root 2 value is 1.414. That is just an approximated value, not an exact value. So for the calculation sake, we used to do that, but actually they are not perfect values for those things. So irrational numbers means pi, root 2, root 3, root 5, all this comes under irrational numbers. Now rational numbers. Once again, these rational numbers are divided into two things, two concepts. One is fractions and the other one is integers. Fractions and integers. See, fraction means we all know, generally the p by q we call that as a fraction. Anything which is written in the form of p by q we call that is a fraction. These fractions are divided into two things majorly. One is proper fraction and the other one is improper fraction. What is proper fraction means? Proper fraction means if denominator is greater than numerator, then we call that as a proper fraction. That means 1 by 2 is a proper fraction. 1 by 3 is a proper fraction. 3 by 4 is a proper fraction. 5 by 6 is a proper fraction. In all this, the denominator value will be greater than the numerator value. So these type of values we call them as proper fraction. Proper fraction. We know one is numerator and 2 is denominator. And what is improper fraction? Improper fraction means if the denominator is less than the numerator, we call that as an improper fraction. Example for that is 3 by 2, 4 by 3, 6 by 5. All this we call them as improper fraction. But What usually we do to these improper fractions is, we will try to write these improper fractions in mixed fractions. That means 3 by 2 we usually write it as 1 by 2. 4 by 3 we will write that value as 1 by 3. 6 by 5 we will write that as 1 by 5. 1 by 5. So usually we will not leave the improper fraction like that. We will convert that improper fraction into a mixed fraction. We will convert the improper fraction into a mixed fraction. Not only in this, in our entire mathematics concept, remember one thing, we never write our answer in improper fraction. Either we write it in proper fraction or in mixed fraction, but we never write our answer in improper fraction. Remember this one carefully. We never write our answers in improper fraction. We always write our answer either in proper fraction or mixed fraction. Mixed fraction. Okay, remember this one. So now based on this we will have the fractions. And sir, you will have one more thing. We will also have repeating decimals. Repeating decimals. What is meant by this repeating decimals means? Please observe here, ma. Okay, for your understanding, we will discuss them in a detail. Why? Because they may ask us questions from that area also. What is meant by this repeating means? We already know that, sir, is 0.3333 is a rational number or not? First doubt, most of the students like this, if 0.3333 is a rational number or not. Now what we will do with this 0.333 here is, please observe here, ma, what we can write this 0.3 bar, right? I will assume this as some x for time being. I will assume this value as some x. Now what happens to this x here? If I multiply 10 on both sides, okay, multiply 10 on both sides. When I multiply 10 on both sides, what will happen to this? 10x will become, when I multiply 10 to this becomes what? 1 3 will come to this side. This will become 3.33333, something like this, right? So now what I am going to do is, I will write it as 10x is equal to 3 plus 0.3333. I can write, yes, I can write. Now 10x value will become what for me here? 3 plus x. Why? Because x is equal to 0.333, something like this. So now when I send x to this side, what happens to that? It will become 9x is equal to 3. Now what is my x value? X is equal to 3 by 9. X is equal to 3 by 9, which in turn becomes what? 1 by 3. So that means 0.33. That means repeating decimals are all rational numbers. So 0.3333 is a rational number. Why? Because I am able to write it in the form of P by Q. I am able to write it in the form of P by Q. Okay, not only these students, please observe this one. Why? Because they are asking the questions from this area also, which is very, very important for us. Okay, what actually is happening here is, there is a simple shortcut for this one. 0.3 bar, right? Actually it is 0.3 bar. So how many numbers are repeating? How many digits are repeating here? Only one digit. Only one digit. So what I can write is 3 by 9. Directly I can write that as 3 by 9. One digit is repeating, so 3 by 9. For example, if I have 0.32 bar, that means 0.32323232, something like this. So I can write that as 32 by, how many digits are repeating? 2 digits. 32 by 99. 32 by 99. And for example, if I have something like this, 0.453 bar. So all the 3 digits are repeating, right? That means 0.453, 453, 453, 453. So I can write this as 453 by, how many digits are repeating? 3 digits are repeating. So 999. 999. Okay, this is one set of questions. Okay, well and good. Next set of questions from the same concept is, why I am telling this is, nowadays they are asking questions from this area also. What is the value of so and so is equal to? Something like that they are asking. That is the reason. Or there is a question something like this, 0.425 bar. The bar is only for 25. 0.425252525. That is the thing. So now what happens to this is, how you need to write is 425 by, how many non-repeating are there? One non-repeating is there. How many repeating are there? 2, right? So for the 2 repeating you have 99. For non-repeating take a 0. For non-repeating take a value as 0. For example, if I have 0.25 bar, bar is only for 5. Bar is only for 5. Then you need to write this as 25 by 1 is repeating 9, 1 is non-repeating 0, 90, 25 by 90. And similarly, anyway, we are done with this one. We will see here. And similarly, if you have a question something like this, 1.42 bar, 1.42 bar. Now please here, till now in all the examples what we have taken is 0, 0, something like that. But for the first time we are taking it as 1.42. We are taking it as 1.42. Now how we need to solve here? How we need to solve this one is, what we need to do is 142 minus, what do you have? 1. Oh, sorry for this. Please observe here. 425 minus 4. 425 minus 4. If there is any non-repeating, please subtract it. So that means this value becomes here for us 421 by 990. Okay, and similarly, what happens to this value? 25 minus 2. 25 minus 2, that means this value becomes 23 by 90. This value becomes 23 by 90. 23 by 90. Like this, you need to solve the things for us here. Okay? Please be careful. Okay? Now, similarly, please see here what we have. 142 minus 1 by 99. So, this becomes 141 by 99. Like this. If there are any non-repeating values, please be careful and try to solve them accordingly. Okay, you need to subtract that non-repeating from this one. Okay, non-repeating from this one. And try to solve these values. Okay, this is very, very important. Now we will see the next one. Sorry, where we are here. We are discussing about the proper and improper fractions. So this is regarding the proper and improper and fractions. Next, when it comes to the integers, we all know integers are divided into, once again, positive integers, negative integers and 0. I didn't mention here, but integers are divided into negative integers, positive integers and 0. 3 categories. 0 is neither positive nor negative. Remember this one. 0 is neither positive nor negative. So we should not consider that in this category or in that category. 0 is a separate integer. So we will have negative integers, 0 and positive integers. Usually we call this 0 and positive integers as whole numbers. Okay. We call that 0 and positive integers as whole numbers, and negative integers, as usual, we know it about the negative integers. Next, when it comes to these whole numbers, we know 0 and natural numbers. Natural numbers are what? Natural numbers are nothing but the counting numbers. Counting numbers. Natural numbers are counting numbers, and we will have 0. We have 0. Okay. Now, next. See here, these natural numbers are further divided. These natural numbers are further divided based on the factors which it will have. So what are the things we will have? These natural numbers are divided into 3 categories once again. One is prime numbers. That means based on the factors. The other one is 1 and the other one is composite numbers. So these natural numbers are further divided into 3 categories: prime numbers, 1 and composite numbers. Prime numbers means what? The numbers which have exactly 2 factors. Exactly 2 factors. We call them as prime numbers. Definitely it should have 2 factors, and those 2 factors are what? One factor will be 1 and the other factor will be itself. Okay, the numbers which have exactly 2 factors, we call them as prime numbers. Next, 1 will have only 1 factor, that is 1 itself. So 1 is neither prime nor composite. Remember this one. Why? Because later while substituting the values or verifying the things, these things will matter a lot. So 1 is neither prime nor composite. You should not include that 1 in any category. What is meant by composite numbers? The numbers which have more than 2 factors. Okay, the numbers which have more than 2 factors, we call them as composite numbers. We call them as composite numbers. So Like this, the natural numbers are segregated based on the factors which they have. Okay, next. Now, about the prime numbers, we have some data. What we can say is, having exactly two factors, those numbers we call them as prime numbers. 2 is the only even prime number. See, out of all the prime numbers, if you observe carefully, except 2, all the remaining numbers are odd numbers. So 2 is the only prime number which we have. Next, the only prime number ends with 5 is 5 itself. And along in similar statement, we can go with the 2 also. The only prime number which ends with 2 is 2 itself. So 2 and 5 are the prime numbers which ends with 2 and 5 only. Means with the digit 5, the only prime number which ends with the digit 5 is 5, and the only prime number which ends with the digit 2 is 2 only. Okay, next. All the prime numbers ends with 1, 3, 7 and 9 except this 2 and 5. Except 2 and 5, all the remaining prime numbers ends with either 1, 3, 7 or 9. Okay. Actually here we will have all the odd numbers except 5. Except 5 we will have all the odd numbers. Next. All the prime numbers greater than 3 can be expressed as, all the prime numbers which are greater than 3 can be expressed as 6k plus or minus 1. Actually this is 6k plus or minus 1 or 6k plus 5. 6k plus 5. So all the prime numbers greater than 3. If I take 5, what I can write 5? 6 into 1 minus 1, right? 6 into 1 minus 1. If I take 7, what I can write? 6 into 1 plus 1, right? That means I can write either 6k plus 1 or 6k minus 1. All the prime numbers I can write either 6k plus 1 or 6. It doesn't mean that all the numbers which are written in the form of 6k plus 1 is a prime number. Vice versa is not the case here. All the numbers which are written in the form of 6k plus 1 plus or minus 1 are not prime numbers. The reason is, see here, 25. Take for example 25. Is 25 a prime number? No, 25 is not a prime number. But I can write 25 as 6 into 4 plus 1. By seeing this, sir, I can write this 25 as 6k plus 1. So I can call that as prime number? No. All the prime numbers can be written as 6k plus or minus 1. But all the numbers which are of the form of 6k plus or minus 1 are not prime numbers. See students, these basics are very, very important. Why? Because based on these concepts only they are asking questions. We should understand these small things which are very, very important. Next, there are some type of numbers which will have exactly 3 factors. What are those 2 numbers? What are those numbers means? See, we will have some numbers which will have exactly 3 factors. Exactly 3 factors. What are those numbers means? They are the squares of prime numbers. Squares of prime numbers. We will see. What is 2 square? Which is 4. How many factors does 4 have? 1, 2 and 4. If you see 3 square, how many factors does 3 square have? 3 square is 9. 1, 3 and 9. Okay. We will go with little bit higher number, 7 square. What is 7 square? 49. What are the factors for 49? 1, 7 and 49 are the factors for 49. We will go with 11 square. What is 11 square? 121. What are the factors for 121? 1, 11 and 121. From this we should understand one basic thing, that the squares of prime numbers will have exactly 3 factors. And what are those factors? Those factors are 1 itself and that prime number. Please see here. 1, 2 and 4. 1, 3 and 9. 1, 7 and 49. 1, 11 and 121. Like this. So if anyone says that there is a number which have exactly 3 factor, means immediately you should get idea that yes, that should be a number, that number should be a square of any prime number. That number should be square of any prime number, then only it will have exactly 3 factors. Then only it will have exactly 3 factors. Okay, the same thing we are writing here. Any number which is the square of a prime number will have exactly 3 factors. Any number which is a square of prime number will have exactly 3 factors. The factors of p square is where p is a prime number, is p square, p and 1. Just now we have seen. For 7, what are the factors? 1, 7 and 49. That means 1, p and p square, where p in that case is 7. And next, now we will see a question. A prime number contains the digit x at units place. How many such digits of x are possible? How many such digits of x are possible for me? So what they are telling, a prime number contains the digit x at units place. So what are the chances for units place in any prime number we have? Usually, put 2 and 5 aside, it can be 1, 3, 7 and 9. Along with this, there are 2 more prime numbers which will have the unit digit as 2 and 5. Even only 2 numbers that are 2 and 5. That means the units digit of x, how many possibilities are there for me? 1, 2, 3, 4, 5 and 6. How many possibilities are there for me? 6 possibilities are there. For example, the same question. The prime number contains the digit x at units place and x is a 2-digit number. X should be greater than 2-digit number. Okay. X consists of a minimum of 2 digits. Okay, we will call it in different manner. X consists of a minimum of 2 digits. Then how many such digits of x are possible? Minimum of 2 digits, right? In that cases, 2 and 5 will get eliminated. Why? Because the digits, the prime numbers which ends with 2 and 5 are 2 and 5 only, which are 1-digit numbers. So we will not take into them consideration. So we will have 4 for that answer. The answer for that question will become 4. Why? Because x should have a minimum of 2 digits. In that case, the answer will become 4. But here there is no such case. So no need to worry. We should also consider 2 and 5. So our answer here becomes 6. Now we will try to see one example. Okay. From this concept, we will try to observe one example. That is, what is the least 3-digit number with exactly 3 factors? What is the least 3-digit number with exactly 3 factors? This is a question. What is the least 3-digit number which have exactly 3 factors? So now, just now I told you, which numbers will have exactly 3 factors? Squares of prime numbers will have exactly 3 factors. So now tell me, which is the least square of a prime number? We will see. First, 100 is the least 3-digit number, right? Usually 100 is the square for what? 10. But 10 is a composite number. We don't require that also. Now what is the next prime number immediately after 10? What is the first prime number immediately after 10 is 11. So 11 square will become what? 121. So I can say that 121 is the first or the least 3-digit number which have exactly 3 factors. 121 is the least 3-digit number which have exactly 3 factors, and those factors will be 1, 11 and 121. Now similarly, tell me, what is the least prime number which have exactly 3 factors? Sorry, 3-digit number, not 3-digit, 4-digit number which have exactly 3 factors. 4-digit number means, what is the least 4-digit number we have? 10,000. What is the least 4-digit number we have? 10,000. Okay, good, superb. Now what is the nearest? Not 4-digit, right? So 1000 only. I will consider 1000 more, sorry. So 1000 is the least 4-digit number. Okay. So 1000 is what is the perfect square nearer to 1000? We all know that 31 square is what? 961. 31 square is 961, which is a square, I mean prime number, but that is not matching. What is the next square, I mean prime number after 31? What is the prime number after 31? 37. 37 is the next prime number. So what is 37 square we have? What is 37 square? What you will get? 37 square is 12 and 169. Okay, 37 square is 1369. So 1369 is the, no need to worry how I have written this one, that is waste of time. We will not concentrate on those type of silly things. But 37 square, what is the value of 37 square? 1369. So 1369 is the least 4-digit number which have exactly 3 factors. And what are those factors? 1, 37 and 1369 itself. Okay. Like this, they may ask us questions regarding these factors. Next, we will see some of the standard questions from these number systems. Usually, we will see, and then we will move to concepts. Okay, slowly we will move to concepts, but we will see to the things. Two statements S1 and S2 are given below, followed by a question based on these prime numbers. With the knowledge which we have till now, we will try to solve it. Okay, the statement 1 is n is a prime number. Okay, with only statement 1. Now, they are telling that n is a unique natural number between 10 and 20. And statement 2 is n leaves a remainder 1 when divided by 4. That is my statement 2. That is second statement. Now see, they are saying that if n is a unique natural number between 10 and 20, then what is n? That means between 10 and 20, I need to choose n value based on the given statements given for me. So if I think that n is a prime number, so how many chances do I have for prime number? 11, 13, 17 and 19. Can I tell a unique answer for this one? That means, can I pick uniquely that 11 is my n, 13 is my n, 17? With only statement 1, can I tell my answer? No. Why? Because with statement 1, I can say there is a possibilities for 4 numbers. Now I will see the second one. N leaves a remainder 1 when divided by 4. So now tell me, what are the numbers from 10 to 20 which leaves remainder 1 with n? 13 will leaves a remainder 1. Am I correct or not? When I divide with 4? Yes. Next, 17, it will leave a remainder 1 when I divide it with 4. Next, 21, but 21 is out of our range. Why? Because we want only the digits from 10 and 20. So by the second statement, how many digits, how many numbers are there for me? 2 numbers. But what they are telling, n is a unique. Am I able to tell only one answer here? No. With statement 2, I cannot tell my one answer. But now I will try to combine these 2 statements. By combining these 2 statements, can I tell my answer? That is, can I tell what is the value of n here? Now please observe here. 13 and 17 there, 13 and 17 here. By using both the statements also, I cannot tell a single answer. I was not able to tell a single answer here. So with the help of both the statements, okay, S1 and S2 together are not sufficient to answer the question. By using both the statements also, I cannot tell my exact answer for n. It can be either 13 or 17. Okay, so by using both the statements, even though by using both the statements also, I was not able to tell my answer. Okay, like this they are going to ask the questions based on statements. See, these statement based questions are very, very important. Why? Because you can see a minimum of some around 10 to 12 questions from the statement based things. So please observe these type of questions, how we are solving them. Okay, next one. Now see here, consider 2 statements S1 and S2 followed by a question. Okay, P and Q both are prime numbers. P and Q both are prime numbers. Now take random values. P and Q both are prime numbers. They are telling that P and Q both are prime numbers. And is PQ an odd integer? That is my question. Question is whether PQ is an odd integer or not. Okay, so odd integer or not means there is no need that definitely you need to prove PQ as odd integer or PQ as even. You need to tell that yes or no. Are you able to tell the answer yes or no here? That is mandatory for us. Now P plus Q is an odd integer, right? And they are telling, sorry, first one is P and Q both are prime numbers. I will take 2 different values. Both are simply prime numbers, right? So I will take 2 and 3. What is the product? I will get 6. I will get 6. For example, if I take 2 numbers as 3 and 5, what is the product? I will get PQ value I will get is 15. In one case I am getting odd number and in one case I am getting even number. Can I tell exactly that always even number or always odd number? No, right? It can be even number or it cannot be, sorry, it can be even number or odd number. So by using the first statement alone, I was not able to tell what is my answer is exactly here. Okay, now I will see my second statement. What is the second statement I have here? P plus Q is an odd integer. P plus Q is an odd integer. When usually you will get P plus Q with an odd integer, tell me? By adding which type of numbers? See, if you add an even number with even number. What is the output? A even number. Am I correct? If I add an even number with odd number, what is the output I will get? If I add an even number with odd number, definitely an odd number. If I add an odd number with odd number, what is the output I will get? An even number. If you have any doubt, just take examples of small numbers. 2 plus 4, what it is? 6. 2 plus 3, what it is? 5. Next, 3 plus 5, what it is? 8. So, when I add an even number with odd number, then only I will get an odd number. That means what indirectly is telling is, either of P and Q is an odd integer. Either of P and Q is an odd integer. Okay, now, if one of them is an odd integer, now tell me PQ value will become what? PQ value becomes what for us? See here, odd integer, right? Both P and one of them is an odd integer. That means one will be even, the other one is odd. So when you multiply even with odd, what is the output you will get? Even with odd, always an even number, right? Always an even number. Take a random example, 2 3s are, or else 14 5s are, always an even number. So when you multiply an even number with odd number, always you will get an even number. So by using second statement, what is our answer for this question? Is PQ an odd integer? Our answer for this is no. PQ is not an odd integer. Always no only, right? Always no only. Always no only. Always it is a no. Always it is no. So from this we can tell. Now here one more doubt you will have. What is the doubt which we can have here? P plus Q is an odd integer, right? So I can take any one value as 0. There is a chance, right? There is a chance. If I take one value as 0, then what will be my PQ? If I take one value as 0, what will be my PQ? My PQ value becomes 0. My PQ value becomes 0. Then also what will be my answer? No, right? Always no only. So if you take 0 also, PQ value is not an odd integer. Why? Because 0 is what? Neither even nor odd. 0 is neither even nor odd. So always my answer is no. Always my answer is no for that. Because of that reason, statement 2 alone is sufficient to answer the question. Why? Because my answer will be always no only for it. With the help of statement 2, my answer will be always no. Okay, understood. Because of that reason, statement 2 alone is sufficient to answer the question. Next one. See, these co-primes are very, very important. The entire, almost some around 25% of questions from this concept depends on this number system concept depends on this co-primes. This co-primes concept is very, very important. So, which two numbers we call them as co-primes means, understand, HCF of any two numbers, if the HCF of any two numbers is 1, then we call them as co-primes. Then we call, by seeing the word prime, don't think that co-primes means always it contains prime numbers. By default, prime numbers will become co-primes. Why? Because if you take prime number as a pair in with any number, usually the HCF will become what? 1. See, if I take 3 with 8, if 3 is a prime number, if one of the two numbers is a prime number, by default they will become co-primes. By default they become co-primes. And 3 and 5 will be co-primes. Why? Because both are prime numbers. And at the same time, 8 and 9 are also co-primes. Actually speaking, 8 is composite number, 9 is composite number. But 8 and 9 are co-primes. The reason is the HCF between them is 1. Okay, any numbers whose HCF is 1, we call them as co-primes. We call them as co-primes. For these co-primes, see here, not only this, any two successive numbers. Any two successive numbers will be always co-primes. Okay, any two take 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, like this. Any two successive numbers will be always co-primes. Remember this one. Okay. So that means co-primes means it can contain any numbers, whether prime number, composite number, one prime, one composite, both primes or both the composite numbers. Anything can become co-primes. And the examples for them are, you can write 3, 5, both are prime numbers. 3, 8, one prime and one composite. Next, 15, 16, both are composite. 15, 16, both are composite and both are, when I say jointly, they become co-primes. So when you use co-prime means definitely we will have a minimum of 2 numbers. We can also say 3 numbers also co-primes if their HCF is 1. If their HCF is 1, we can also call them as co-primes. But this co-primes is very, very important. We will use this concept very frequently in this number system. Okay. Next one. Now, to know the number of factors, usually what will happen is, see here, just now we told you that our natural numbers are classified based on what? Factors, right? Based on factors, we decided prime numbers, composite numbers and 1. Okay, the natural numbers are divided based on the factors. So how we will find the factors? For example, if I take 12, what are the factors for 12? 1, 2, 3, 4, 6 and 12. These are the factors for 12. As 12 is a small number, you can easily count them and you can say that the number of factors for 12 is 6. Similarly, if I want to tell the factors for 120, even though it takes some time, but okay, that one is also fine. We will try to get the answer for that one. That is also good. But if I want to tell the number of factors for 600, then how you are going to get the answer? For that only, we have a technique called prime factorization. With the help of prime factorization, we will try to solve the problems. Now, what is this prime factorization? How we are going to solve the problems based on this prime factorization means, please observe here carefully. Now, in this prime factorization, what we will do is, we will divide the given number with prime numbers. That means 120 with 260, only prime numbers. 2 30s, 2 15s and 3 5s. Okay, we will divide the numbers with only prime numbers and we will write the given number as a product of prime numbers. That means what I can write 120 as? I can write 120 as 2 cube into 3 power 1 into 5 to the power of 1. I can write 120 as 2 cube into 3 power 1 into 5 to the power of 1. Okay. So now after writing like this method is called prime factorization. Right, expressing the given numbers as a product of prime numbers is called prime factorization. Okay, we have written, good, superb. After writing it, take the powers and add 1 to them and multiply them. That means what? What is 2 power here? 3. So 3 plus 1 into, what is 3 power here? 1. 1 plus 1 into, what is 5 power here? 1 plus 1. So now what happens here? 4 into 2 into 4 2s are 8, 8 2s are 16. That means 120 will have 16 factors. That means simply do the prime factorization for the given number and then add 1 to the powers and multiply them. So that you will get the number of factors for the given number. The same thing we have written here. Please observe here. We have written the same thing here. To express any number as a product of prime numbers is called prime factorization. So number of factors we will tell based on this. Number of factors, if n is a number which can be written in the form of 2 power p into 3 power q into, these are prime numbers, right? That means we are expressing n in the form of prime numbers. Okay, now then total number of factors is equal to, I told you right, add 1 to the powers and multiply them. So P plus 1 into Q plus 1 into R plus 1 into S plus 1 and so on. Like this, we will find the number of factors for the given number. Number of factors for the given number. Next, odd factors means we all know except 2, all the remaining prime numbers are what? Odd numbers. Except 2, all the remaining prime numbers are odd numbers. So eliminate the power of 2. Here 2 power is P, right? So except 2 power, write all the remaining numbers. Same thing, Q plus 1 into R plus 1 into S plus 1 and so on. Except 2 power, calculate for the remaining numbers. Next, even factors means, if you know that we don't have any special formula for even factors, to get the even factors, we need to find the total number of factors and we need to subtract odd factors from it. Why? Because we have the formula for total factors and odd factors. We don't have any specific formula for even factors. So you need to find the total number of factors and then subtract it from the odd factors. Okay, next, number of prime factors means simply add the powers. Simply add the powers. See, very rarely we will use these concepts. Okay, very rarely we will use these two things, sum of the factors, very rarely. See, please once go through the formula, but we will not use that much frequently. There will be one more thing, that is product of factors. Product of factors. Then that one will become what? N power number of factors by 2. N power number of factors by 2. For example, if they ask you, you should have a knowledge, right? So the product of factors is equal to n to the power of number of factors by 2. But very rarely they will ask about product of factors and sum of factors, but they will majorly ask these total factors, odd factors, even factors and number of prime factors. Okay, you should remember these 4 things. Sum of factors and product of factors, you should have a knowledge regarding that. Okay, they may ask us. The reason behind that is a long story. It is not that much required for us. Okay, next one. Right? What is this meant by these unique solutions and multiple solutions? See students, we should understand this concept very clearly. Why? Because earlier also, while solving in one problem, if you observe here, if n is a unique natural number, that means you should have a unique solution, means only one solution. So what is meant by this unique and this multiple solutions? We should have some basic knowledge, not the complete knowledge, but at least we should have some basic knowledge regarding these unique solutions and multiple solutions. Just for knowledge sake. What is meant by this unique and multiple? See, x plus y is equal to some 5. X plus y is equal to some 5. So usually we call this is a line equation. Line equation. So here we will have infinite solutions. Infinite solutions for x and y. We will have infinite solutions for x and y. Sir, how you are telling infinite solutions for x and y means? Please observe here carefully. Please observe here carefully. I will take x value as 1 and x value as 0 and y value as 5. It is possible, right? Okay, I will write the number line also for better understanding. Okay, like this, something like that. If I take x as 0 and y value becomes what? 5 for me. Okay, if I take x as 1, what happens to y value? It becomes 4 for me here. If I take x as 2, what will be my y value here? 3. Understood? Sorry, 2 and 3, it will be somewhere around here. 2 and 3. 2 and 3. If I take x value as 3, what about my y value? 2. If I take x value as 2, what will be my y value? 1. Sorry, x value as 4, y value will be 1. If I take x value as 5, what will be y value for me here? 0. Okay, if I take x value as 6, y value becomes what? -1. If I take x value as 7, what will be y value for me here? Minus 2. So if you observe, this is a line equation, right? Usually we call that as a line equation. So you can have infinite points on this, right? That means you will have infinite solutions on x and y. You will have infinite solutions for x and y here. You will have infinite solutions for x and y here. Now, when we will have the unique solution means, please observe here, that is nothing but multiple solutions. If you have a single equation, you can take multiple solutions for that. You can take multiple solutions. But when you have two equations, definitely you will have the unique solutions for it. Definitely you will have the unique solutions. Why? Because you need to solve for x and y individually. What happens? This is 5 and so y will get cancelled. 2x value will become what for me here? 8. So x value becomes 4. If x value is 4, what about y? Y value becomes 1. So you will get a unique solution. You will get a unique solution means exactly you will have x value as 4 and y value as 1. Like this, you can find the unique solutions. Okay, this is the difference between unique solutions and multiple solutions. So if you have two equations, definitely you will get a unique solution. If you have a single equations, you will have multiple solutions. You will have multiple solutions. Remember this one. Okay. Next, when it comes to divisibility rules, we should know definitely the divisibility rules. So, what is the divisibility rule of 2? I will give you a quick, what we can say, look into it. The rule for 2. What is rule for 2? All the even numbers. All the even numbers are divisible by, all even numbers are divisible by 2. Okay, good. Next, what is the rule for 3? Rule for 3 is very, very important. Why? Because they are framing many questions from this rule from 3. What is rule from 3? Sum of the digits. Sum of the digits should be divisible by, sum of the digits should be divisible by 3. That means, for example, if I want to check whether 369 is divisible by 3 or not, means what I should do, I need to add them. 3 plus 6 plus 9. What it is? 18. I need to check whether 18 is divisible by 3. Yes, 18 is divisible by 3. So that means 369 is divisible by 3. If it is not divisible, then 369 is not divisible by 3. Like that. What is rule for 4? We will use this application. So we will use the applications of these rules. That is the reason you need to know this one. If last two digits should be divisible by 4 or last two digits are zeros. Last two digits are zeros. Either they should be divisible by 4 or last two digits should be zeros. Then that number is exactly divisible by 4. That means, for example, if I want to check 4, 3, 2, 4, 8, whether this number is divisible by 4 or not, means I will check only the last two digits. I will check only 48. Is 48 divisible by 4? Yes, 48 is divisible by 4. Then this number is also divisible by 4. Or else if the last two digits are zeros, that means if I have something like this, last two digits are zeros, right? So directly I can say that that number is divisible by 4. Last two digits are divisible by 4 or last two digits are zeros, then I can say that that number is divisible by 4. Remember students, as I have already told you, number systems we will discuss in a detailed manner. We will not leave any portion from this number system. That is the reason, even though you know these divisibility rules, I am once again repeating it. Okay. Now, what is rule for 5? What is rule for 5? Any number which ends with 0 or 5, except 0. Any number which ends with 0 or 5 is divisible by 5. Any number which ends with digit 0 or 5, which is that number will be divisible by 5. What is rule for 6? What is rule for 6? We all know. A number which is divisible by both 2 and 3. The number which is divisible by both 2 and 3, then that number will be exactly divisible by 6. A number which is divisible by both 2 and 3, then that number is exactly divisible by 6. That means the number should be exactly divisible by 6. Okay. Next, rule for 7, that is not that much important for us. We will see it later while solving the problems. Why? Because there are many methods for this rule for 7. Very frequent, what we can say, we will not use that much for very frequently. So that is the reason we are not going to learn about it. Next, rule for 8. What is rule for 8? It is similar to 4. In case of 4, we have checked the last 2 digits, right? In case of 8, we will check the last 3 digits. We will check the last 3 digits. If the last 3 digits are divisible by 8, then that number is divisible by 8. Or last 3 digits are zeros. If the last 3 digits are zeros, then also that number will be divisible by 8. Okay. Next, what is rule for 9? Rule for 9 is similar to rule for 3. Okay, there the digit sum, we will do the digit sum there. If the digit sum is divisible by 3, then that is divisible by 3, right? Similarly here also, we will add the sum of the digits of the given number. We will see the sum of the digits of the given number. If that sum is divisible by 9, then that is divisible by 9, else it is not divisible by 9. 9 is also very important. For example, if I need to check whether 369 is divisible by 9 or not, what I will do? 3 plus 6 plus 9. What is the sum? 18. I will check whether 18 is divisible by 9. Yes, 18 is divisible by 9. Then that number is divisible by 9. Else it is not divisible by 9. Else it is not divisible by 9. Next, rule for 10. Very simple. If the unit digit is 0, then that number is divisible by 10. That's it. Next, rule for 11. This is also very important for us. Okay, sorry. Let me add a page here. So, rule for 11. Rule for 11 is also very important for us. Why? Because we will use that one very frequently. What is the rule for 11? We have the sum of the digits. The sum of the digits at even positions and odd positions. We will add the digits. So for example, I need to check is 1331 is divisible by 11 or not. I will divide it into 2 groups, 1, 2, 3 and 4. Odd positions as one group and even positions as one group. Okay, I will divide it into 2 groups, odd positions and even positions, starting from right side. So 1, 2, 3, something like this. So now, if you add the odd positions sum, what is the odd position sum? 1 and 3 are the odd positions. So, okay, here that is so. What happens to this one? It becomes 4. What is even position sum here? Here also same, 0. So, if the difference between the sum of odd positions and even positions is 0 or 11, in some exceptional cases, you will also get the sum as 11, the difference as 11. So, those numbers are divisible by 11. Here I can say that 1331 is divisible by 11. We need to find the sum of even positions and sum of odd positions and observe the difference between them. If the difference is either 0 or a multiple of 11 or 11, then that number is divisible by 11. Next, rule for 12. From here onwards, please observe one thing carefully, students. So usually what is the rule for 12 is any number which is divisible by both 4 and 3. By both 4 and 3, then that number is divisible by 12. Then that number is divisible by 12. Sir, why we are taking 4 and 3? Why not only 4 and 3? You see 12 I can get by multiplying 6 with 2, right, sir? Why you are taking 4 and 3? See here, usually how we take the pairs means we will take the co-primes. Co-primes. Just we will go one step backward. If you observe rule for 6, what we have taken a number which is divisible by what? 2 and 3. A number which is divisible by 2 and 3, then the number will be divisible by 6, right? We have written. So if you observe carefully, without knowing to us, 2 and 3 are what? Co-primes. So like this, to write the divisibility rule of any number, you can take the multiples of any 2 numbers, but those 2 numbers should be what? Co-primes. Co-primes. Because of that reason only, we are taking the divisibility rule of 12 as 4 and 3. 4 and 3. Now tell me what will be the rule for 15? Rule for 15? Rule for 15 will be any number which is divisible by both 5 and 3. Why? Because 5 and 3 are co-primes. 5 and 3 are co-primes. So any number which is divisible by both 5 and 3, then that number will be divisible by 15. Now similarly tell me, what is the rule for 16? What is the rule for 16? Rule for 16 is last 4 digits. This one will go continuously, ma. 4 last 2 digits, 8 last 3 digits, 16 last 4 digits. Like this, it will go on increasing. Okay. Next rule for 18. What is the rule for 18? Actually, how we can write 18? Generally, in general, how you can write 18? 9 2s are 18 you can write. You can write 6 3s are also as 18. But we will take that a number which is divisible by both 9 and 2, that number will be divisible by 18. I will not take 6 and 3. Why? Because 6 and 3 are not co-primes. 6 and 3 are not co-primes. I will take 9 and 2. I will check whether the number is divisible by 9 and 2. If the number is divisible by 9 and 2, then I will say that that number is divisible by 18. 18. Like this, take the product of two co-primes. For example, if I want to write the divisibility rule for 30. If I want to write the divisibility rule for 30. Sir, you can say, sir, 30, I can write it as 10 into 3. Those two are co-primes. Yes, you can take that one. Or else 6 into 5. If the number is divisible by both 6 and 5, then that number will be divisible by 30. You can take that one. Or 15 and 2. Anyway, both are same. Both are same. 15 and 2 and 6 and 5 more or less the same thing, right? To check the divisibility rule of 15, once again you need to check with 3 and 5. That means you need to check anyway with 3, 2 and 5. The same thing. Like this, we will write the divisibility rules for any required number. Any required number. So simply the product of two co-primes. We will see any two co-primes product and we will check whether the given number is divisible by those co-prime numbers or not. If they are divisible, then that number is divisible by the given number. Like this we are going to see. Now we will see some of the questions from these divisibility rules. Two statements are given below followed by two conclusions. Statements 1. All the numbers are divisible by 2. Okay. The given numbers are divisible by 2. That is my statement 1. Okay. And second statement, all numbers are divisible by 3. All numbers are divisible by 3. All the numbers are divisible by 2 and all numbers are divisible by 3. Conclusions. All numbers are divisible by 6. Correct, right? Why? Because all the numbers are given set of numbers are divisible by 2 and the given set of numbers are divisible by 3. Then obviously the given numbers will be divisible by 6, right? Yes, the first one is true. Next, all numbers are divisible by 4. Is it correct? Is it correct? No. See here, for example, all the numbers divisible by 2 and 3 means, first of all tell me what are the set, what is the set I need to take? Nothing but indirectly multiples of 6. He is telling us indirectly take the multiples of 6. Then only the numbers will be divisible by 2 as well as the numbers will be divisible by 3, right? First of all, my data set will be how I can choose, how I need to make my data or how I need to take my numbers means take the LCM of 2 and 3. What is the LCM of 2 and 3? 6. So my given numbers are what? The multiples of 6. Now check, are these numbers, all these numbers are divisible by 4 or not? No. 6 is not divisible by 4, 18 is not divisible by 4, 30 is not divisible by 4. That means my second one is false here. My second one is false here. So what I can say is only conclusion 1 is true here, conclusion 2 is false. Conclusion 2 is false. Okay. Next one. How many integers are there between 1 and 100 which have 4 as a digit but not divisible by 4? I need to choose numbers from 1 to 100 which have 4 as a digit but it should not be divisible by 4. First of all, tell me what are the numbers which have 4 as a digit. We don't have any other choice. We need to write the numbers. So 4, 14, 24, 34, from 40 onwards, 41, 42, 43, 44, 45, 46, 47, 48, 49, and then we will have 54, 64, 74, 84 and 94. These are the numbers which have 4 as a digit, right? But are not divisible by 4. That means I will cancel the numbers which are divisible by 4. 4 I will cancel, 24 I will cancel, 40, 44, 48, 64, 84. These are the numbers which have 4 as a digit and are divisible by 4. So that is the reason I am cancelling them. So now count the remaining numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my answer here is 12. So there are 12 numbers which have 4 as a digit and are not divisible by 4. Okay, next. A digit n is greater than 3 is divisible by 3 but not divisible by 6. Okay, they are telling that n is a number which is divisible by 3 but not divisible by 6. What does it mean? Tell me. Divisible by 3 and not divisible by 6 means what? Tell me what is the data set I need to choose here. I need to choose the odd multiples of 3. Greater than 3 means odd multiple. First odd multiple of 3 is 9. Okay, 15, 21, 27, like this. I need to choose them. Why? Because if I take the even multiples, definitely they will be divisible by 6. So my data set is here what? And what I can take here is 9, 15, 21, 27, so on. Which one of the following is divisible by 4? Which one of the following is divisible by 4? Now I need to check which one of these equations satisfies this one. 2n. 2n means what? I will take the first one. 18. Is 18 divisible by 4? No. So this is gone. 3n. 3n means 9 into 3, 27. That is divisible by 4? No. Next 2n plus 2. 2n plus 2 means what? 18 plus 2. 18 plus 2 is 20. Yes, 20 is divisible by 4. Okay, we will check that with another one. 15 2s are 30. 30 plus 2, 32. Yes, 32 is divisible by 4. That is satisfied. We will check one more. 42 plus 2, 44. Yes, 44 is divisible by 4. Next 56. 56. That means this condition 2n plus 2 will satisfy the given condition. Okay, understood the concept? First of all, we should take the data set for n. What are the values of n we can take here is odd multiples of 3 except 3. Why? Because n is greater than 3. N is greater than 3, so I cannot take 3. After that, I can take the remaining odd multiples of 3. Okay, next. Right, next one. Let xyz be a 3-digit number where x plus y. See students, how you will assume a 3-digit number or 2-digit number means this is very, very important. Why? Because every time they are asking at least one question from this area. You should know this one very well. Okay, how you should assume a 3-digit number or 2-digit number. This is very well. For example, if xy, you can write xy as a 2-digit number. While writing, you can write. But when you want to perform any mathematical operation, how you need to write is, we all know, in our schooling we have done. If there is 32, how I can write 32 ma? How I can write 32? 3 into 10 plus 2 into 1. Am I correct or not? Why? Because 3 is at tens place and 2 is at units place. So I can write this as 32. I can write this as 32. 32. And similarly, if you observe here, xy. How I can write this? X into 10 plus y into 1. Why? Because x is at tens place and y is at ones place. If I have a 3-digit number, x, y, z, then you can write it as x, y, z. But when you want to perform any mathematical operation, that means when you want to add it or multiply it, you should write it in this form. X into 100 plus y into 10 plus z into 1. Remember this one. This point is very, very important. How to assume a 3-digit number or 2-digit number means you can take them as xy or xyz, something like that. But when you perform a mathematical operation, definitely you should write them in this form and then only perform the mathematical operation. Okay, then only you will get the correct answer, else you will get a wrong answer here. Now we will see our given question. Let xyz be a 3-digit number. Okay, x, y, z is a 3-digit number. Then where xy plus y plus z is not a multiple of 3, they are telling very clearly that x plus y plus z is not a multiple of 3. Then xyz plus yzx plus zxy is not divisible by. So first of all, xyz, I need to add all these things, right? So how I will write? 100 into x plus 10 into y plus 1 into z. Next what I have? Yzx. Yzx means what? 100 into y plus 10 into z plus 1 into x. Next I have zxy. So that means 100 into z plus 10 into x plus 1 into y. Now I need to add all these three numbers. So when I add all these three numbers, what I have 100x, 10x and 1x. Overall I will have 111x. Plus similarly I have 100y, 10y and 1y. I will have 111y and 111z. So that means what I can write this value overall is 111 times of x plus y plus z. 111 times of x plus y plus z. Now they are telling that this number is not divisible by. This number is not divisible by. See here students, very clearly what I can write this 111. I can write this 111 for timing as 37 into 3 into x plus y plus z. Now is not divisible by. They are asking us it is not divisible by. Please see here, this is not divisible by 3, right? Is it divisible by 3 or not? Yes, it is divisible by 3. Why? Because if I divide it with 3, 3 will get cancelled and it is exactly divisible by 3. So 3 is not my answer. 3 is not my answer. For time being, put that 9 aside. For time being, put that 9 aside. We will see it. See 37. Yes, if I take 37 here, 37 will get cancelled and it is exactly divisible. So 37 is also not my answer. If I take x plus y plus z, x plus y plus z and x plus y plus z will get cancelled. That one is also not my answer. Obviously 9 will be my answer. Obviously 9 will be my answer. But for a technical proof, what we will do is, I will take this divisible by 9. 3 ones, 3 threes. Now see here, you may have that, sir, x plus y plus z can be divisible by 3. No, they clearly mentioned in the question x plus y plus z is not a multiple of 3. That means this 3 will not cancel x plus y plus z and 37 is also not going to cancel by 3. So that means the given number which is of this form will not be divisible by 9. Will not be divisible by 9. So like this, we are going to solve the questions from this divisibility concept. Right? We will see another concept in our next session, and at the same time we will practice many questions. First of all, we will learn the concepts slowly by seeing some examples. After finishing the complete concepts, then we will solve the questions in an holistic manner. Okay? Thank you.